Welcome to Mr. Joyner's class, your chemistry class. This is all going to be about Chapter 3, Section 2, Changes in Matter. And this is all going to be about physical and chemical changes. Last time it was about physical and chemical properties. So I don't want to get the two confused. Properties are things that you can observe. Changes, well, it's changing in ways that property can change. So some essential questions to answer. What is a physical change and what are several common examples? What defines a chemical change and how can you recognize a chemical change? And how does the law of conservation of mass apply to a chemical reaction? We'll also be introducing some new vocabulary such as law of conservation of mass, physical change instead of properties, and chemical changes instead of chemical properties, and phase change. Special note on phase change, there will be a quiz question on that. And remember from last time, we were talking about phase changes is just matter going from solid to liquid to gas to even plasma. So solid, liquid, and gas, those phase changes in particular are physical changes. They're not going to be chemical changes because the composition still stays the same. So get this down in your notes about physical change and phase change, getting those definitions down. Physical change is a change that alters the substance without changing its composition. A phase change is a transition of matter from one state to another, such as boiling, freezing, melting, condensation. One they didn't mark down here, sublimation. All these describe phase changes in chemistry. So be sure to get that down and the examples especially, and also add sublimation to that. On your notes, be sure to write down what a chemical change is and the examples. A chemical change is a change that involves one or more substances turning into new substances. That's the key or the buzzword there, new substances. That's called a chemical change. Examples are decomposition. That's a fancy word for breaking down into simpler compounds or elements. Rusting. So that's also a fancy word. A fancy word for that is oxidizing. So rusting, like iron turning into rust, well, that's all because it chemically reacts with oxygen. Exploding. You could also say combustion. Exploding and combustion, hand in hand there. Burning. So if you burn your food, yes, you have changed it chemically into something else like charcoal. Or oxidizing, which is similar to rusting. I guess they call it that differently depending on the substance, are all terms that describe chemical changes. Okay, now we're talking about the law of conservation of mass. This states that mass is neither created nor destroyed. Make sure you get that down. A chemical reaction is conserved based on the law of conservation of mass. In any reaction, the mass of the reactants then will always equal the mass of the products. So you can see sort of an equation right there. So remember, the reactants are one or two things or three things that are reacting, that are on the left side of this arrow, which is often called the yield arrow. So the reactants are on this side, make note of that. And the products are on the right side of this yield arrow, make note of that. So whatever the mass is over here, let's say the mass is 16 grams for the reactants, it's also going to be 16 grams for the products, however you add them up. And that's why eventually when we get to balancing chemical equations, you have to balance those so that you can figure out how much on this side and how much on that side winds up equaling 16 grams on each side, or whatever it is on each, but it has to equal on both sides. So often people ask, well, okay, then when something rusts or burns, what happened to all that mass that was there? Well, it blew away. If you had a closed system, you would see all that ash and all that smoke that came from that candle or from that burning log. If you weigh all the ash and smoke, it would equal the same as before and after the experiment, the burning. And so let's work out a conservation of mass problem. You have 10 grams of mercury 2 oxide. We put that Roman numeral there. We'll talk about that more later to indicate mercury's charge. This is in powder form and is placed in an open flask and heated until converted to liquid mercury and oxygen gas. So this is broken down into two individual components, mercury and oxygen. So we've changed it. It's no longer mercury oxide, it's mercury and oxygen, two separate things. So this would be a decomposition reaction. The liquid mercury has a mass of 9.26 grams. What is the mass of oxygen formed in the reaction? So remember, they have to be the same on both sides. The liquid mercury has a mass of 9.26 grams. What is the mass of the oxygen? Well, we started off with 10 grams of mercury oxide. So what do you think we have to do? That's right, you're going to have to subtract. So we analyze the problem, and then we take our known, we make a list of our known and our unknown and put it in that question format. And that's what we're looking for, is the mass of the oxygen. So we just take what we know about the law of conservation of mass. That has to be equal on both sides. So it has to equal 10 grams on both sides. So then we just simply solve for oxygen by subtracting the mercury. So we take 10 minus 9.26, and that's going to give us our answer. Okay, let's try another one. The sum of the masses of two products equals the mass of the reactant. This verifies that the mass has been conserved. So if you add 9.26 plus the mass of the oxygen, it should equal 10, and that would obey the law of conservation of mass. That's a good way to check to see if your answer is correct. So, what is a physical, let's see if we've answered these questions. What is a physical change? That's right, a physical change is a change in a substance where it still has the same composition. So this would be like melting or boiling or sublimation, things like that, or even fold it up, cut it. It's still the same. It's still the same composition, made of the same thing. And what are several common examples? We've mentioned those. What defines the chemical change? Well, that's right. Chemical change is any change where it changes the composition of the substance. So it changes into a new substance. How can you recognize these chemical changes? Well, you can recognize them by the new products they produce. There's also some other things that this didn't mention that I would be remiss to not mention here. But if it gives off light, write that down, by the way. If it gives off light, if it suddenly heats up or cools down on its own without you introducing that energy from an outside source, if it produces some kind of solid that doesn't dissolve in, we call it a precipitate. It doesn't dissolve in there, so it just, there's a solid that forms and it winds up sinking or floating, sinking to the bottom or floating to the top. That's a precipitate, and that is another product being made, so it's a chemical change. And you know, if it gives off fumes without you having heated it, so if it unlike, for instance, if you boil something and it turns into, well, you're introducing heat to it. So if it turns into something completely different, a new substance, that's the main thing to go off of, is that you have a chemical change. And then how does the law of conservation of mass apply to chemical reactions? That's right. Whatever reactants and their mass is on at the beginning of the reaction is going to be the same at the end when you have new products. Even though new products are made, you're just reshuffling atoms, really. So let's say back to the mercury oxide. Mercury oxide was your reactant. You decomposed it in a reaction, and you got mercury and oxygen separate. They're still the same things, right? Mercury and oxygen. So you're still dealing with the same elements. They're just rearranged in a new way and in that way become new substances. And so conservation of mass, you're not introducing new elements, and therefore you're not introducing new mass. Thank you.